So I've already told you that I've been born and raised here. I did graduate Coraloo and decided that I needed to see a big city. So I went east, and well, not central Canada, went to Ottawa, to Carleton University, and got my Bachelor of Journalism. And you might think that's a very large difference from going from Carleton back to UNBC to do a Master of Science. I was there and I concentrated in science journalism, and I just honestly have a very love affair with food. Anything to do with food, and the more you learn about it, the more I started going to farmers markets and learning where my food was coming from, the more I realized that this is where my path was taking me. So I came back to UNBC and met Scott and started working on food-related topics in the area and started my master's. And I'm scared to say this now, after Jillian's talk, that I am the future farmer that has no land, no practical knowledge, growing practical knowledge, but I am hoping that I'm moving towards the greenhorn status one day. I could also call myself an urban farmer. So this was my biggest harvest to date. It took up my entire kitchen table, and it came from a community garden plot because where I live currently is a cement backyard. So I'm slowly learning the on-hand skills to become a farmer. So when we started the research, we got a great opportunity to start looking at grain production in the region, and as we talked to different producers, they were the ones who identified what we were going to be looking at. So they did choose barley as the grain of interest rather than the other ones, and specifically water stress. They weren't as interested in looking at nutrients or temperature stress, but specifically water. And the more you read about it, the more this becomes relevant not only on a local scale and what producers want to see, but on a larger global scale. So we started with the research question: how do hybrid and heritage varieties of barley respond to different levels of water stress? To qualify how I'm going to be using these terms, because I'm sure they're used differently, when I say hybrid, I mean a variety of barley that has been bred to exhibit specific traits: high yield, disease resistance, that sort of thing. When I'm talking about heritage varieties, these have been selected to a degree, but what's happened when the theory around this is that you would be going out and just choosing the biggest, happiest seeds from your land rather than specifically breeding for traits. So, as I said, why barley, why water? That was definitely something that the producers that we were talking to identified as issues. And why northern BC is fairly obvious. I have a huge connection to the land. I didn't grow up on the land. My grandparents were the last to be farmers in the area, but we still own land, farmland in the area, and I feel a really strong connection to place here. So I'm a northern BC girl, and it's going to be pretty hard for you to rip me away from the region again. The reason we chose to look at heritage and hybrid cultivar varieties of barley is because we wanted to see if there's a difference in how they were going to start to respond to stress. So with any plant, you're never going to have a plant that's going to be able to give you extremely high yields summer and summer and summer with all the varying conditions. The more you breed towards a specific trait, you're narrowing that genetic structure, and you're going to potentially increase vulnerability. So we wanted to see that over the years, as we've done these breeding programs, do the hybrids respond to stress differently than these heritage varieties that have been selected more in a more natural process. And so with that, a big concept that we've been looking at is adaptive capacity and yield and how those relate to each other. So for our terms, adaptive capacity is mostly how that plant responds. Is it going to change from a really hot, dry summer to a really cold, wet summer, or is it going to be able to have stable yields throughout that? And what would the yield potential responses be? I'm not going to spend a lot of time on the greenhouse study we did. I've talked to, I think, a lot of you at the booth over there, and I know this is supposed to be much more about feedback and learning from you, but I didn't want to disregard it completely. And it's also really good practice for my defense when I defending my thesis and eventually graduating from UNBC. So we did do a greenhouse study. We wanted to kind of look at the genetic structure, so the genetic responses, and if there was a variation. So we wanted to make sure it was a controlled environment. And we did look at 10 different varieties of barley. 6 of those were hybrids, most of them being grown in the area, and 4 were heritage varieties. and we measured what we call phenology, and that's just basically how the plant grows over time. So that would be days to heading, days to maturity, and the difference between those being the grain filling, specifically for grains. Allocation, so where was the plant putting all of its resources? Was it into the roots, to the shoots, into the heads, and how did those relate to stress? And obviously yield, because you can't really look at a plant and not look at the end product, which as farmers, you know, is probably one of the most important things. So to get an idea of what it looked like, I worked it in the enhanced forestry lab at UNBC, and this is what they looked like when they started out. They were pretty pampered plants. All right, they each got a huge pot by themselves. It's definitely not seeding capacity, what you would see in the field, but we needed to distinguish those differences. So this is within the first couple days of germination. And then we separated them out and put some fans in there to make it seem like there was wind. And if you use the fans, you can see how much they grew. This is towards once they've gone to heading. So we pretty quickly got a jungle going on in there. So I'm a big picture person, so you can now see what I was working with. This was 2 summers ago, so 2012, the summer of 2012. And I'm just going to go over some really brief results. So this is days to heading, and the reason days to heading is important because it's during that time that the plant is going to be getting all of its vegetation, which is going to give it lots of photosynthesis, and it's going to be those resources that it's going to be used to eventually put into the head and into the yield. The time up to days to heading is where the plants determine how many kernels per head or kernels per spike the plant is going to produce. So when you're looking at the graphs, along the bottom are the 10 varieties that we used. The first 6 are the hybrid varieties, so AC Lacombe, CDC Cowboy, Xena, CDC Bold, Dolly, and one we actually found what was called McBride, that was developed specifically for northern colder climates. It's not being grown, I haven't met a producer who's currently growing it. I found the seed down south, but because it was bred for our region, we wanted to include it. And then the green box is going around the different heritage varieties. So Black Hullis, Bear, Himalayan, and Hortium zeochrythin, which is a different species of barley. So it's not the cultivated species that we use for the rest of them. And there is a producer currently growing Himalayan in the region, so that's one of the reasons we chose that. As you can see, at least for days to heading, it's pretty consistent. There's not a lot of treatment response. So when I'm talking about treatments, the darkest blue was under saturated conditions. And so they had wet feet, sat under water for the entire growing season, and then it decreased to extreme drought from there. So optimal to extreme. So the darkest blue means more water, the lightest blue means a little bit of water. So they're pretty uniform. You can see as I go through the next couple graphs, the hybrids are all responding quite similarly to each other, and there's just a greater range of responses that you're seeing in the heritage varieties. And all the little alphabetical numbers just is a statistic looking at how significant those differences were in the treatments. So when you're looking at days to maturity, that's obviously important in a region like this. Along the scale is how many days did it take, days to maturity. And the difference between heading and days is where you're going to determine grain weight. So there's different components related to these measures that go into the yield, which is why we were looking at them. And in the end, they all kind of matured around the same time, except for in the optimal and the saturated conditions. Once you give it a lot of water and you're not giving it that dry time, obviously it's taking them much longer to reach maturity. And the grain filling period matches more so what this looks like. What you can see is while for the heritage varieties, you're still getting those extra days under more water, but the difference between those days is much less. It's not such a big spike that you're seeing between treatments. You're seeing much less treatment response in the heritage varieties. Root-shoot ratio is something we've used for adaptability. So how much resources is the plant putting to above ground versus below ground weight? The idea is that as a plant gets more stressed out, there's less water available or too much water, they're going to be putting more allocation to their roots because it's going to give them greater access to more water in the long run. So the greater the root-shoot ratio, what we were saying, the more stronger adaptation you're seeing. Oh, go back, sorry. So what we can see here is one of our heritage varieties, Black Hullis, has a huge root-shoot ratio. This suggests that it's giving you a much larger adaptation, but it also has a large amount of variation within it. Those error bars, so these are just the means, so giving you a much larger variation, but it's also, this variety gave you the complete opposite trend in everything you measured it in. And Himalayan as well. So Himalayan has responded much more similarly to the levels of a hybrid, but still a very strong, a really high root-shoot ratio. And finally, yield, because this is obviously really important. So when you're looking at this, again, all the hybrids are looking pretty uniform. They're all responding the same way. So you see you had that stronger, what we're considering a higher adaptation capacity in the Black Hullis. You're also getting an extremely low yield potential. So while it can adapt and it doesn't really matter what the conditions are, the yield is not something you're going to be similar to what you're seeing in the hybrids. However, if you're looking at Himalayan, it is quite comparable yield-wise to the hybrids. And then again, it's showing that reduced treatment response, which is so just a slight more adaptation. So those are just really brief. I'm still in the process of all the analysis and trying to get through it, but I just wanted to give you an idea of what we were finding. And our main findings were that heritage varieties do have a greater variation in how they're going to respond to stress. So that means you can't just choose any heritage variety. They're not all created equal. You could have small yield potentials or larger yield potentials. You really need to know the seed that you're working with and the land that you're working on. Whereas the hybrids, you're seeing a lot more of a uniform response and a higher yield potential. Those, at least from a greenhouse genetic level, it's much more predictable what you're going to get. There are quite a lot of limitations doing a greenhouse study. You're not taking into account different soil types, different climates, microclimates. We used a pretty neutral substrate. It was 50% sand, 50% peat is what these were grown in. So there's a lot of aspects that wouldn't translate into the field. And therefore, you would need multi-year field trials with the varying soil types to really understand how these would look in the region. And there's a lot of difficulties with that. You do need multi-years because you never know what kind of summer you're going to get as producers. I don't really need to tell you that. One summer is going to be really wet and one summer is going to be really hot. So you need to, if we do move to field trials, you're going to have a multi-year set, and that also requires multi-year funding. That also requires a lot of groundwork, trying to find fields that you know enough history on that you can work with, and a lot of those type of things. And to bridge the gap between what we were doing in the greenhouse and what's actually on the field, I did a lot of farm stays during my first year. As I said, I didn't grow up on a farm. I was part of the 4-H group, but I had a really small garden, and I think I did photography. So it's not necessarily the same thing. I was around cattle, and I was around all the other 4-H members, but it wasn't the same. I needed to get back on the land and make sure that what I was doing and how I was talking and what I was looking at was actually applied and relevant to producers. And as I started researching this, I'll make sure I have lots of time. As I started researching this is something that's been more and more common. So it's actually a lot of research is being done, not only here and in America, but a lot in Australia, a lot in Europe, about working with producers. And they use this terminology called networks of practice or communities of practice. And basically what that's talking about is groups of people who are working towards a common goal. So in this case, we're doing it towards farmers, but you could also do it towards people who are working in an office together or working in a mill together. I definitely have worked in the mill, and there's definitely a camaraderie that you build in the lunchroom. You know, you're all waiting to make it to a water break. You don't want to work on the hot dryers anymore. There's definitely things that connect you guys as you work together, and the same thing applies to farmers. And what they found as they do these studies is that generally farmers are organizationally weak. They work long hours, geographically isolated from each other. So I would say this is a huge exception. We're all here today, so obviously it's not that we don't have, producers don't have the capability of doing it, it's just they're extremely busy. And we need to find ways to be able to bring us together and share knowledge like we are today. But on the other hand, farmers have a very strong working identity. No matter who you ask, they all believe in what they're doing, and they work extremely hard for it. And the more you talk to them, the more the feedback that we're getting and what we're learning is that there's a huge lack of understanding of farm-level practices, both from scientists and policymakers. So to try to bridge this gap is why we did the farm stays, why I went out and did field trials, is so that I can have much better understanding of farm-level practices, and opportunities and challenges, both short-term and long-term. And these are some photos of that. On top was a farm trial that I did where I got to learn much more about alfalfa and a bunch of different forage crops. Studying barley, it's amazing how quickly you can get isolated into one topic. So these have been really good to give me, the field days really helped me get a much broader understanding of what was going on in the area. And I stayed on a chicken farm, and that little girl is the best chicken whisperer you'll ever meet. She can catch any chicken, any size. So if you need her services, I'm pretty sure they're trying to rent her out. So for the first summer, I did do three farm stays is what I was able to do, and I basically lived out of the back of my truck. My dad taught me how to do that. You just put a piece of plywood in the middle, put everything underneath, and sleep on top with my little guard dog. And I basically gave free labor from 1 to 2 weeks at different farms, 2 in Vanderhoof and 1 in Quesnel. We had initially planned to do much more than that, but the greenhouse ended up being much more demanding than we thought. And with that, I conducted interviews with them, I recorded what I did, and I did anything from from feeding the chickens and collecting eggs, to one day where a farmer honestly just handed me a bucket of nails and a hammer and said, go fix the fence. So I stood in the middle of the field by myself and fixed a fence for 8 hours. And it really just gave me a much better understanding of what producers were doing, and then it was all those conversations, sitting in it, okay, anybody from UNBC should probably cover their ears because I wasn't allowed to do this. Sitting in a tractor and going through a hay field and just talking about when is the right time to harvest forage, the difficulties of all the different things. A lot of these conversations really just gave me a much better understanding of what was going on. And our findings weren't all that, Scott mentioned it quite a bit, and you looked at the literature, our findings matched it quite well. There's a huge lack in connection between knowledge, research, and the practitioner. We have to find a ways to be able to exchange all these together. And one of the biggest things as you started talking to producers is that we needed to start incorporating previous research. Trust me, if we've been cultivating barley for tens of thousands of years, a lot of this has already been studied. There's no point in me reinventing the wheel. There are variety trials going on everywhere. So how can we use the information that's already there, that's already been provided, and how can we connect that into the research as we move forward? And a big part of that were the experimental farms. So the experimental farm that was in Prince George as well as Smithers. And a lot of people talked about those specifically in the illustration stations they had and the field days that they had and how that worked to connect producers together, using those services to host 4-H meetings and organizations on all those things. So that became really, really important in our research. And just broadening the scope of our research question. A lot of people, when we brought them together and we said, this is what we found about barley, we'd like to move to field trials, and I had a conversation today about this, they all laughed. They're like, that's great, so we can grow barley. How are we going to process it? How are we going to be able to afford the machinery to have the tractor and the combine? How are we going to dry the grain? There's all these things down the line that we hadn't even really thought of as researchers because we're not growing fields of barley. So there's a lot of those questions that came up, and we realized we had to broaden the scope of what we were looking at and find out what would be needed and most useful for producers. So that brought us to our second year of research. And that was, again, as I said, to explore the history and the context of agriculture research in the area, primarily through the experimental farms, and to expand our research extension and broaden our scope. So trying to make sure to relay the results of our greenhouse trials and talk to more producers, get more people involved into these partnerships so that we can work side by side and have them direct the future of the research. I'm going to provide a huge disclaimer before we move on to the experimental farms. While I worked on aspects of it, all 99.9% of the work was done by a fantastic research assistant that we had, Megan Sterling. So I'm kind of just giving a really brief overview of what she's found. But Scott also is extremely involved. So if there's questions around the experimental farm research and what we found, I'm sure he would also be willing to help answer those questions. So I believe when we first started out, we wanted to find all these documents. When the experimental farms closed down, there wasn't a centralized way of organizing all the reports and information that they had. A lot of that information was packed up in boxes and taken home and put in basements of the different people who worked there. So with that, what we wanted to do was starting to recapture a bunch of this information and find out how much of it would be useful moving forward. I think a lot of that became really difficult. We were doing a lot of this work in the summer, and it's really, really difficult to get a hold of any producer in the summer unless you're offering free labor. Once I told them I would work for them for free, a lot of people were signing up. So with that, there became a lot of issues with that, and a lot of people didn't want the records broken up. So they were a little bit resistant to pass over all these boxes if any of it might be lost, and that's for very good reason. A lot of work had gone into those. So that aspect of it kind of shifted to look at the experimental farm structure. How did it work? How did it not work? And how did the centralization of these farms and essentially the closures of both the Prince George and the Smithers farms, how did that impact the area? First of all, the thing that when we talked to producers who had accessed the farms, basically said that they played a huge role in the agricultural community by providing that visual reference. It's great that I can stand up here and talk to you about barley. It's a million times more useful for you guys to go out to a field of barley and look at it yourself. You guys have a much better understanding of what you're looking for and the questions you're asking. So the experimental farms provided that. And basically the closures have resulted in a gap in contextual knowledge and its extension. So there are still lots of field trials going on. There's still a lot of variety trials going on. But if you're working from information coming from the Peace, or you're working from information coming from the prairies, and you're working in Quesnel, McBride, Smithers, that information might not translate directly. It's really important that this information is coming contextually. It's growing in the area, so it's relevant to where you are. And from that, she was able to catalog various documents, and so we at least have an idea of where some of these documents are and who has them, because they definitely are coming from multiple people. And this is actually a picture that I found from Exploration Place that is the Prince George experimental farm. And they actually have hundreds of photos. It's pretty spectacular if anybody's interested in doing that. And then this is the part that I'm a little bit more aware of, was the extension. So I spent last summer traveling to different communities and sharing the results of our study and just talking to producers. So I went to a lot of different agricultural fairs. This picture is from Smithers. So again, I traveled around in my truck with my dog. It was pretty early in the morning, so she was given a good stretch. And just wanted to have a better understanding. And through that, and through trying to widen our scope and what we've been talking to people with, and trying to get feedback, we've learned a lot. And we've learned a lot not only on how we can improve what we did, but how we can move forward. And I'll just skip that part, because I really want to make sure we have some time for questions. And with this, the main findings is that when I'm working with the Omanika region, and that's a huge geographic zone, and a lot of people have already talked about that today. And I've also included Quesnel. Officially in all the research proposals, I've included Quesnel in the Omanika region, and that's obviously because I hold the place dear in heart, so I have been able to work with a lot of producers in Quesnel. And the landscape isn't uniform. So the issues that people are working with in Bulkley Valley aren't the same as the Nechako, aren't the same as Robson Valley, aren't the same of the Caribou. So with this, the different landscape offers different challenges, and it also offers different opportunities, what producers are seeing as opening areas for markets and different ways they can move forward is not going to be the same as people I'm talking to Quesnel as in Vanderhoof. So when I'm in Vanderhoof, they're all very interested in forage. A lot of them are interested in barley. They want to see these trials move forward. When I moved to Quesnel, I talked to people in Quesnel. A lot of it turned to market gardens. People wanted to learn the different vegetables they can grow here. We have a bit more of a growing longer season down here, and you can do a little bit differently. Whereas you move over to Smithers, and they're much more interested in quinoa and doing crop trials and rebuilding those orchards that were there that aren't as much anymore. So there's a lot of different opportunities, a lot of different challenges, and we need to make sure that we can move forward in that way. Some of the concerns that were voiced were all uniform. Weeds was the biggest thing that I heard while I traveled around, was the biggest challenge that producers are working across the board, are trying to manage weeds, or what they said, the lack of management from anybody of dealing with that. So that's kind of what we've been working on here, and that's part of why I'm here today, and why I think a bunch of people have been able to write on my booth over there different opportunities and how they see it. And a big part of this is the growing opportunity at UNBC. I keep going back to how UNBC calls itself the university in the north for the north. Well, we have agriculture in the north. So there's a lot of opportunities and a lot of capacity that can be grown at UNBC to start filling in these gaps that were missed. How we do that and how we move forward isn't clear, and it's not going to be clear for a while, but there's a lot that can be done. I know I mentioned it to a couple people now, that through this work that we've been able to get almost all of your courses towards your professional agrologist designation are now offered at UNBC. So you can walk into the registrar's office and you can find out which courses you can take to do that. And that's huge, especially for producers with children who might be interested in going in it. Instead of going to Alberta, instead of going south to find out and get this training, they can get most of it up at UNBC. And as we found out, you can also slip into a master's program underneath the title of Natural Resources and Environmental Science. To my awareness, it hadn't been done to any extent before. All you need is a willing supervisor and some funding, and it's definitely possible. There's at least 5 graduate students right now working on different agriculture-related projects at UNBC. So with that, and I know we only have about 15 minutes left, and I want to make sure that we have lots of time for questions. We are moving into phase 3. And so with our main objectives for that in this coming summer, and this is where I want all of your information, and if you're interested at all in contacting me, please let me know, is we are trying to develop a framework for applied agriculture research. So as we move forward, what would work best for you guys? What kind of system would work the best? Is it there are aspects of the experimental farm that we can pull from, or is it something else, the reasons it didn't work that we need to change? And with that, building regional research strategies and priorities. So at the end of this year, I'm really hoping that I can be able to come out with documents saying this is what Northern Cariboo wants. This is what they feel are the priorities for research in the future. This is what the Bulkley Valley wants. This is what Robson Valley wants. So that's the larger goal of what we're working on this year. And through building that capacity at UNBC, we have soil scientists. We have people who work with plants. We have people who are working with a lot of native, medicinal uses for plants in the area, wild harvesting. There is that chunk of knowledge at UNBC. We need to find a way to be able to make those connections, not only for producers knowing that they're there, but for faculty knowing that there's an interest on the ground here. And trust me, I can't tell you how many of the faculty members know about my research and talk to me about it all the time in the halls. And that's the great thing about UNBC. It's really small, you get to know people really quick, face to face, and we're all really willing to work with people. And as well as trying to do some more exploration of the records from the experimental farms and trying to make those available to everybody, so that if you want to know about different trials that were being held across Highway 16, you can just click a button and find it online. And how this is all going to work is kind of longer down the road, because it would take a very long time to try to digitalize and make all those documents accessible. And we have to make sure that they're going to be useful moving forward. So we don't want to spend a whole bunch of time trying to take this chunk of information if in the end not a lot of it's going to be applicable moving forward. So there's a lot of this type of work and groundwork that needs to happen. Acknowledgements. So the 3 years of 3 phases of the research have been funded in full by the Amanika Beetle Action Coalition. You guys know a lot about its branch here in the Caribou. So this one's just along Highway 16. To my, it's a long list, but I'll do it really quick. So my committee, Dr. Scott Green, Dr. Cy Transkin, and Dr. Kent Mullenix. Norm Dewick from Glendale Agra, he actually provided all the hybrid seeds to us for free and a lot of that knowledge to make sure we were getting all the nutrients and everything right. My various research assistants over the years, April Havold, Kyla Jensen, Melissa Nitz, Megan Sterling, along with the greenhouse curators, John Orlowski and Doug Thompson, and a whole bunch of really close friends who spent hours washing roots with me in the greenhouse. So if you ever have to cut and wash roots, just make sure you have a good set of friends and offer them some free food and they'll come up. So that would be Addie, Wyatt, Christine, Eric, Becky, and Cam.